Hello, hello. The day is finally here. The day I thought we wouldn't see in quite a long time is here. Like, I can't believe that, but this is the last section on Free Code Camp. If we complete this, and we complete the challenges and the projects, we've not only completed this section, but the entire full stacks curriculum. And we'll basically be done. Free to do whatever it is that we would like to do. I can't tell you how excited I am, and I'm really looking forward to this. These are going to be the things that will basically spearhead the majority of our projects. And I feel a lot of this we've already done, which is great. It's just gonna, you know, further solidify the knowledge that we already have and teach us a few things that we may not have known to begin with. So without further ado, let's jump straight into things and let's see where we go. So let's do the introduction to information security with Helmet.js challenges. Helmet.js is a type of middleware for Express-based applications that automatically sets HTTP headers to prevent sensitive information from unintentionally being passed between the server and client. While Helmet.js does not account for all situations, it does include support for common ones like content secure policy, XSS filtering, and HTTP strict transport security, among others. Helmet.js can be installed on an Express project from npm, after which each layer of protection can be configured to best fit the project. Working on these challenges will involve you writing your code on Glitch on our starter project. After completing each challenge, you can copy your public Glitch URL to the home page of your app into the challenge screen to test it. Optionally, you may choose to write your project on another platform, but it must be publicly visible for our testing. Start this project on Glitch using this link or clone this repository. Let's see if the Glitch link still works for them. Yeah, no, something went wrong. Something went wrong their side. That's fine though. Wow, and we had a direct merge pull request by Quincy himself. Interesting. So this is a slight problem. So if we can't import and we can't view it, not a problem, we'll come back to that. So first thing we need to do is install and require Helmet. Oh, and we're gonna have to enter our link for it to be publicly viewable. I wonder if it will test on a HTTP network. I wonder if we just give like localhost. So we can't clone it, which is a pity. I don't know if there was something wrong with... If there's something wrong with Glitch. Let's check the system status. Doesn't seem to be anything. Everything's running fine. Yeah, because how are we gonna clone this otherwise? Let's just Google glitch clone from GitHub. Wait, how do you do that? Oh, clone from repo. From the new project. Okay, so first, I guess let's get rid of the two empty projects that we just created, which just failed for some reason. Okay, so these two just failed. So just delete this project. And the total turnover. Delete this project. And then new project, clone from GitHub repo, and then maybe the repo link changed. That might have been it. So let's just see if we clone it directly with that link. Will it work? Maybe. Hopefully. Otherwise we're gonna have to manually copy the files, which is gonna be a bit annoying. But we'll do it. Essentially what I'd like to do is develop locally, actually. So even if this doesn't work, we'll see if FreeCodeCamp supports the localhost. Glitch is really acting up today. It's been for a while, but wow. I'm gonna go ahead and download this so long. And save it to our Dropbox. Okay, so information security and quality assurance, there we go, and then just save it in there. And then let me go back and just make sure, was that all helmet based? Yeah, helmet JS. Perfect. They don't want us to edit. Okay, so then we won't edit. Server.js. They don't want us to edit that either. Okay. Package.json. I mean, it's a boilerplate, so what does it really matter, right? Let's just leave it the way that they had it. I'm not gonna like fiddle around with changing things. I'll just leave it exactly the way they had it. What I care about is sticking this over here, adding a folder. There we go. So now we basically can see everything that they had. And we're gonna have to install these things, aren't we? In our dev dependencies, over here, we're gonna have ESLint and all these other things, and prettier and all that. They just want us to have express, that's fine. And node, interesting, 4.4.5. Damn, that's dated when we were working on 10. Yeah, why not? I just need the dev dependencies. So let us do, let's open this up in our terminal, npm install. Let's get all the dependencies and stuff going. Get my ESLint and prettier going. Okay, so that should be it, theoretically. So if I try to add something prettier, it's gonna be like, nope, nope. Cool, so if we open and close, we should be good. It's gonna complain about all the vars. It says do not edit this file. Oh my, but it wants a trailing slash. It's already edited it. Block scoped variables in non-strict mode are not supported until Node.js 6. Oh my god. Oh no. Use fs.promises.read file. What is the issue here? Block scoped. What is the issue here? Block scoped. Block scoped. I wonder if we can update. It says do not edit this file. It's a bit late for that, isn't it? And you're complaining because space or tab after in comment. Apparently that's the requirement. Or can I do that? Is that still valid? Yeah. Oh, I see. So that looks a bit better. If you need a space, let's at least do it that way. Yeah, I'm gonna go and upgrade Node to 10. What's the worst that can happen, right? Can always downgrade it back again if we need to. Try that. npm update. Did I update? Right. Are we complaining now? We're not complaining now. Great. Do not edit this file. Yet we already have. Were we supposed to not edit it at all? Oops. Yeah. Anyway. We're gonna get this running localhost now. And the script that we need to run is server.js, or is it my app? Hold on. Is it server that needs to run, or my app? Wait, I thought this was importing app. Module.exports. Oh, it exports app. Wait, which is the one that listens? The one that listens is myapp.js. Okay. So my app.js. There we go. Cool. Should be online. Okay, 127.0.0.1. There you go. Okay, so it should be right here. Now the question is, after all this, will FreeCodeCamp be able to read So we need to require... Let's see if we'll be able to read it. Test completed, but should be in package.json, which it's not. npm install, what was it? Helmet JS. Let me make sure I got the right one. Oh, it is just helmet. Cool. So npm install helmet. And the helmet is there. Great stuff. Now let us see if FreeCodeCamp will detect that from our localhost. It is in the package.json. I wonder if it's not just about course. app.get package.json. I want to see if this actually gets logged, if it's actually even trying. It might be a course thing. I have a feeling it's course. And they didn't set up course for this. Okay, so the first thing we're supposed to do is require helmet. That's what we've done. Oh, we're supposed to require it as well. Something like that. Okay, so we required it. Maybe it's the fact that we weren't requiring it that was the issue? No? Only thing that I could think of then, it's a course issue. Or somehow the tester is not taking that into account, like localhost wise. Because there aren't any errors. Let me get course set up quick. And then in server, we're going to require and then we're just going to do app.use course options. Do we import app? No, we don't. I think I was supposed to set it up here. So we're gonna do it here. And I didn't mean to require course here, I meant to require it here. And then we just set this to app.use course options. So now cross origin. I don't know if that disables the whole point of helmet, but I just want to see if the tests will run now because of this. Oh, okay, it's doing something now. Now it's getting a response back. Cannot get API package.json. What's it trying to do? What's their test trying to do? Because they try to do something with API. There's package.json. Wait, API is what the variable is. No, underscore API. Oh, there it is. App.use API. Okay, let's see what happens here. And the weird part though is it's supposed to get... Oh yeah, it is trying to do package.json. The weird part is why is it adding API to it? I don't know why their test does that. So if I remove the root, let's just test that real quick. Oh, it's just not found at all. Request response.send file directory name views index.html. So that's if you try to get that. When you use API, your core API, and when you try to get package.json, I wonder if there's any error logs. Oh, these are old errors. Yeah, so that returns the entire page, but it just cannot get API package.json. I don't think I'm understanding how they're doing their tests. Or we might have broken something when we updated everything. Is something posting? Maybe they're posting to API? Actually, let's have a look in the network tab. So when we hit I've completed, it tries to do a get to /_API /package.json. What if we, let's actually try something. Figure out what the issue is. So we get the same issue. What if we just, oh, it's because there's a double slash for some reason. That's why. There's literally just a double slash for whatever reason. There's a double slash that's being added. Why? Where's, do I just remove this? Maybe? What's it trying to do a get to now? No, it's still the same. Where's it getting the double slash from? Close that. Is it in server maybe? Remove that. Maybe just do package.json? Or maybe the directory it's trying to read? There's something that's forcing it to go to the wrong place. I'm gonna figure out which one it is. Just getting a double slash for whatever reason. And where are they adding that? Could it be in file? So the initial request that it makes is a double slash /. And I swear, even if I change this, it's almost like it's not updating. But if I was to manually change this to obviously just a single one, I gotta change this back now. Let's try that again. Resend. Wait. Didn't we get this working? No, we didn't. What was it? Was it just a... What? Or was it directly package.json? Wait, is it even online right now? Yeah, it is. Where was it trying to get to before? This. Okay, that was weird. We did have it initially work at some point. It was a single, no such file directory. Oh, we need a / now. There you go. There you go. With the response being, yeah, there you go. Now we just have to figure out why. Oh, because I am adding a freaking /. Oh my god, this whole time I think there's something wrong with the API. You would think they would be able to strip it, right? If you have it /. No, it was my / there. There we go, we completed the challenge. Let's go to the next one. Oh my god. Okay, hide potential dangerous information using helmet.hide powered by. As a reminder, this project is being built upon the following starter project. Yeah, we know about that. Hackers can exploit known vulnerabilities in Express node. If they see that your site is powered by Express, X powered by, Express is sent in every request coming from Express by default. The helmet.hide powered by middleware will remove the X powered by header. You can also explicitly set the header to something else to throw people off, e.g. app.use helmet.hide powered by set to PHP 4.2.0. Oh, poor PHP. Why is it getting the flag? Cool, that's great. But I want to see what header. What does it respond with? X powered by. Ah, there you go, Express. So if we did it properly. So let's go back to our. We're not going to mess with server.js, we'll just leave it as it is. In fact, I might even completely revert this. They said don't edit the file. So let's make a backup of this just in case, and then I'm going to revert it back to what it was. What it initially was. So I don't want to update that file. I'll update everything else, but I want the tests to be, you know, exactly the same. In fact, let's go to the GitHub repo. Server, that's the one that we're not supposed to touch. And then I'm literally just gonna save this. I'm not gonna. Wait, did I add course to this? No, I didn't. Oh, but I don't want it to like. Ah, it's annoying. It's fine. Hold on, I got an idea. We're gonna do this. Server. There you go. And then I want to just go back to make sure that we still pass the first test. Yeah, cool. Second thing is we can move on now, as long as we don't open server.js. Second part is hide potentially, yeah, so we've already done that. all we need to do is use helmet.hide powered by. Is that all? Helmet.hide powered by, really? Just like that? That sounds like super simple. So let's send another request and see what happens. X powered by is still Express. So that didn't change. Expected course middleware. What's the course middleware? It's not referring to the thing that I added, hopefully. Hopefully not. Because it literally said helmet.hide powered by. But that wouldn't make sense. That would have to be like, because it's a middleware. Wouldn't that be app.use helmet.hide powered by? Because just setting helmet.hide, that wouldn't make sense. That would be like a config thing. I'm pretty sure it should be app.use helmet.hide powered by. Let's find out, see if that made a difference. Expected express to not okay, so we're getting somewhere, but now it wants express to not equal express. Did we miss something? It's powered by express. Yeah, it's still the same. Wait, let's directly look at helmet. Let's see how you're supposed to use hide powered by. You're supposed to use app.use helmet, app.disable. Wait, if you still want, if you're using each of helmet's headers piece by piece, there's a better way to get this header's behavior with the feature built into Express. App.disable. Ah, if you still want to use this module, it's allowed. You can use it as part of helmet. App.use helmet.hide. Yeah, so what's app.use? Or you can require the individual module. Okay. Did we even set app.use helmet? I don't think we did. We required it, but we didn't like start using it. So app.use helmet and then app.use helmet.hide powered by. I think that might be the issue. Okay, so we got something now. It appears you have done something like app.use helmet, but it should be app.use. Damn, I love their smart checks. What would we do without their smart checks? But we still have an issue of X powered by still being expressed. Helmet.hide powered by middleware should be mounted correctly. It should be. We are doing app.use. And we did require no, wait. That doesn't make sense. We've got helmet there. We're trying to use this module. What am I? Yeah, that was silly. That should have been it in theory. The only thing I could think of is either course is messing with this now, or the previous server worked. Let's see, I'm going to revert back to the previous server, but that's obviously not going to help us. Okay, update server with this, and try again. Okay, good. So it's not that. Wait, it was that. Wait, it was that. I think it was just because we updated node and something in the server JS. I don't know if that's a bad thing though now, because we're not supposed to technically edit the test file. Otherwise we need to revert to like the old version of node, and then we can't use any of the modern stuff. Man, that's a tough instance right now. Okay, we'll keep it on condition that the tests are actually working the way they should. So if I uncomment app.use hide helmet powered by, it should fail, in theory, right? So if I run this again, it shouldn't go through. Okay, it's detecting it. And there's X powered by, great. And if I do hide powered by, but without the, wait, did I, just like that. So we call the function directly, we don't, we pass it the function. Okay, it's getting stuck. Timeout has occurred. Okay, good. So it's not just letting us pass for the sake of letting us pass. It actually is passing the test. Okay, good. We leave it then. Screw it. It works. We can like push that. It could be our like push to get up to get it to work with like ES 2015 and Node 10 or whatever. Mitigate the risk of clickjacking with helmet.frameguard. As a reminder, your page could be put in a frame or iframe without your consent. This could result in clickjacking attacks, among other things. Clickjacking is a technique of tricking a user into interacting with a page different from what the user thinks it is. This can be obtained executing your page in a malicious context by means of iframing. In that context, a hacker can put a hidden layer over your page. Hidden buttons can be used to run bad scripts. This middleware sets the X-frame options header. It restricts who can put your site in a frame. It has 3 modes: deny, same origin, and allow from. We don't need our app to be framed. You should use helmet.frameguard, passing with the configuration object action deny. Okay, so app.use helmet.frameguard, frameguard, passing the object action deny. I misspelled frameguard, didn't I? There you go. Okay. And let me change this to framed guard, just to make sure that it's still working the way it should be. Are we still online? No, we're not online. Why aren't we online? Is it because of the fact that there's no framed guard? Framed guard is not a function. Okay, my fault. There we go. And now? Still nothing? Wait, really? Why are we down? Delete the error log, delete the out log. What's the problem? Wait? Your app is listening. Oh, we're fine. Are we good? Oh, we're good. Oh, we're back. Okay. No, don't add the forward slash. There we go. Whew. Mitigate the risk of cross-site scripting XSS attacks with helmet.xss filter. As a reminder, please do not read the as a reminder message. Cross-site scripting XSS is a frequent type of attack where malicious scripts are injected into vulnerable pages with the purpose of stealing sensitive data like session cookies or passwords. That's not fun. The basic rule to lower the risk of an XSS attack is simple. Never trust users' input. As a developer, you should always sanitize all the input coming from the outside. This includes data coming from forms, GET query URLs, and even from post bodies. Sanitizing means that you should find and encode the characters that might be dangerous. Modern browsers can help mitigating the risk by adopting better software strategies. Often, these are configurable via HTTP headers. The XSS protection HTTP header is a basic protection. The browser detects a potential injected script using a heuristic filter. If the header is enabled, the browser changes the script code, neutralizing it. It still has limited support. So let's see if we pass that test, shall we? So the first request, without even making any change, what's it going to try to do? It's going to try to make a get. What did it try to pass in? What was it trying to do? Expected array 3. Oh, did it pass in array 3? But I didn't see that. Where did it pass that in? The request header? That was just a get. Oh, it's not posting. Is it the app stack that's supposed to change? Possibly. Okay, so we need app.use helmet.xss filter. So they're basically teaching us how to use middleware in this section. That's pretty cool. And yes, no, maybe? Timeout has occurred. Oh, it was probably updating the server. Hopefully. Are you down again? Are you down again? Uh-oh. What is the problem now? Error log, nothing in the error. Output is fine. It's still listed as running. What the hell? App.use helmet.xss filter. Oh, am I supposed to pass something in? No, it doesn't specify that I need to pass something in. There's no deny like the what? Wait. Oh, it's working again. Make up your mind! There you go. X-frame options, XSS protection, mode block, X powered by, express. Those are the headers that we got as a response. App stack, third one is XSS protection. Prior to that, what was it? It was frame guard. Oh, so we... Wait, no? Oh, it's a third option that was added, so the fourth item in the array. Okay. Avoid inferring the response MIME type with helmet.noSniff. Browsers can use content or MIME sniffing to adapt to different data types coming from a response. They override the content type headers to guess and process the data. While this can be convenient in some scenarios, it can also lead to some dangerous attacks. This middleware sets the X content type options header to no sniff. This instructs the browser to not bypass the provided content type. No sniffing allowed. Okay, so app.use helmet.noSniff. That makes sense. So these are all the things we're going to want to set then. Prevent IE from opening untrusted HTML with helmet.ie no open. Some web applications will serve untrusted HTML for download, OIE. Some versions of Internet Explorer by default open those HTML files in the context of your site. This means that an untrusted HTML page could start doing bad things in the context of your pages. This middleware sets the X download options header to no open. This will prevent IE users from executing downloads in the trusted site's context. So these are all things you could probably like set up with course, couldn't you, if it's just headers and stuff? But I guess having a framework like Helmet is like tried and tested, so... There you go. How about this? You like that. Good job. Ask browsers to access your site via HTTPS only with helmet.hsts. HTTP Strict Transport Security, HSTS, is a web security policy which helps to protect websites against protocol downgrade attacks and cookie hijacking. If your website can be accessed via HTTPS, you can ask users' browsers to avoid using insecure HTTP. By setting the header Strict Transport Security, you can tell the browser to use HTTPS for the future requests in a specified amount of time. This will work for the request coming after the initial request. Configuring helmet.hsts to use HTTPS for the next 90 days. Oh, that's what we need to do. We need to configure it. Pass the config object max age time in milliseconds false true. Glitch already has HSTS enabled. Oh, we're not using glitch. This might go bad for us. To override its settings, you need to set the field false to true in the config object. We will intercept and restore the glitch header after inspecting it for testing. Configuring HTTPS on a custom website requires acquisition of a domain and a SSL TSL certificate. I mean, if we did this on my domain, this wouldn't be an issue right now. I think this is the part where we're going to have to copy everything to glitch. I mean, we can only try, but I don't think it's gonna work. So app.use helmet.hsts. Is this supposed to be like an object? So max age. It's not time in milliseconds, it's 90 days in milliseconds, right? Because that's why that variable is there. So, unlikely this will work, for obvious reasons. Wait, actually? Did? What? Is it just a setting that's required? Because it did. We're not automatically on HTTPS? Ah, okay. Nice. Okay, that makes me happy. So HSTS. Include subdomains. There it is. Oh, it's strict transport security. Right. I remember that. Okay, so that's fine. Great job. Disable DNS prefetching with helmet.dns prefetch control. To improve performance, most browsers prefetch DNS records for the links in a page. In that way, the destination IP is already known when the user clicks on a link. This may lead to overuse of the DNS service if you own a big website visited by millions of people. Privacy issues. One eavesdropper could infer that you are on a certain page, or page statistics alteration. Some links may appear visited even if they are not. If you have high security needs, you can disable DNS prefetching at the cost of a performance penalty. Helmet.dns prefetch control middleware should be mounted correctly. Okay, let us do that. So app.use helmet.dns prefetch control. There you go. Done. Disable client-side caching with helmet.no cache. Nice. That's what I was actually thinking about prior to the DNS prefetch. If you're releasing an update for your website and you want the users to always download the newer version, you can try to disable caching on a client's browser. It can be useful in development too. Caching has performance benefits, which you will lose, so only use this option when there is a real need. Okay, so helmet.no cache. No cache for you. Set a content secure policy with helmet.content secure policy. This challenge highlights one promising new defense that can significantly reduce the risk and impact of many types of attacks in modern browsers. By setting and configuring a content secure policy, you can prevent the injection of anything unintended into your page. This will protect your app from XSS vulnerabilities, undesired tracking, malicious frames, and much more. CSP works by defining a whitelist of content sources which are trusted. You can configure them for each kind of resource a web page may need: scripts, style sheets, fonts, frames, media, and so on. There are multiple directives available, so a website owner can have a granular control. See HTML5 rocks, key CDN for more details. Unfortunately, CSP is unsupported by older browsers. By default, directives are wide open, so it's important to set the default source directive as a fallback. Helmet supports both default source and default source naming styles. The fallback applies for most of the unspecified directives. In this exercise, use helmet.content security policy and configure it, setting the default source directive to self. The list of allowed sources must be in an array. In order to trust only your website address by default, set also the script source directive so that you will allow scripts to be downloaded from your website and from the domain trusted-cdn.com. Hint: in the self keyword, the single quotes are part of the keyword itself, so it needs to be enclosed in double quotes to be working. Okay, so this one's a little more complex. Oh, that's cool. Right, so you would want to configure them individually. So app.use helmet.content security policy, and then we need to specify default source should be self, like that. Let's first try with that and see what happens. Oh, self. And is it supposed to be in an object? That's the one thing I'm wondering now. The other thing is script source, which is supposed to be trustedcdn.com. Or from your website, meaning self, I guess. Self? Something like that? Why the double quotes? Why the double quotes for self? Did they explain it? The single quotes are part of the keyword itself. Oh, okay, so I don't need it for trusted CDN then. Just like that. And then self needs the double quotes. Like so. Is that good? Your CSP config is not correct. Yeah, no shit. Let's look at an example of how to do this. I assume it's an object that it needs. Yeah, it is. Oh, it's direct. Wait? Yeah, directives, yeah. Default source. So it's kind of what we were doing now, except it needs to be in a key called directives. So directives. And then it would have been fine. Like so, according to that. Well, the one is at least fine. Expected default source self script source self trusted CDN to equal default source self script source self. I messed something up. Did it specify something about? Oh, the directive it did, yeah. What did I mess up here? Oh, we're missing a. There you go. That should be it. Cool. Configure helmet using the parent helmet middleware. apt.use helmet will automatically include all the middleware introduced above, except no cache and content security policy. But these can be enabled if necessary. You can also disable or configure any other middleware individually using a configuration object. We introduced each middleware separately for teaching purposes and for ease of testing. Using the parent helmet middleware is easiest and cleaner for a real project. So apt.use helmet, yeah. So what do they want me to do? No tests, it's a descriptive challenge. So just, yeah. Cool. Bcrypt hashes are very secure. Wait, what's this got to do with helmet though? Weird. Okay. Bcrypt hashes are very secure. A hash is basically a fingerprint of the original data, always unique. This is accomplished by feeding the original data into an algorithm and having returned a fixed length result. To further complicate this process and make it more secure, you can also salt your hash. Salting your hash involves adding random data to the original data before the hashing process, which makes it even harder to crack the hash. Bcrypt hashes will always look like, which does have a structure. The first small bit of data is defining what kind of hash algorithm was used. The next portion defines the cost. Cost is about how much power it takes to compute the hash. It is on a logarithmic scale of 2 to the power of cost and determines how many times the data is put through the hashing algorithm. For example, at a cost of 10, you are able to hash 10 passwords a second on an average computer. However, at a cost of 15, it takes 3 seconds per hash. And to take it further, at a cost of 31, it would take multiple days to complete a hash. Damn. A cost of 12 is considered very secure at this time. The last portion of your hash looks like one large string of numbers, periods, and letters, but it is actually 2 separate pieces of information. The first 22 characters is the salt in plain text, and the rest is the hashed password. To begin, add bcrypt as a dependency in your project and require it in the server. Submit your page when you think you've got it right. Okay. Where do they have their bcrypt though? That's just something I want to know. On their GitHub page, do they even have that somewhere? Because I don't remember seeing it in their server JS. Oh wait, this is completely different. This is bcrypt boilerplate. Bcrypt boilerplate. So why did they... This was Helmet. Why did they add bcrypt to Helmet? Oh dear. Someone might have accidentally merged them. Okay, because we're no longer using the same project. Well then, let's just go ahead and grab this. Just download it quick, make a new project. I'm just going to call it information security with bcrypt. Or what can we call it? Because I know we're going to use bcrypt later on, it's just that should have been its own section. And yet they have it as a different package altogether. Let's see how simple this is going to be though. This server. Oh, it needs FCC testing. Okay. Let me bring that back out because I did delete that. Do we need .profile? Let's check. Do we need .profile? No? No, we don't. Okay, cool. I'll delete the rest. And what's in package.json? I'm not gonna worry with like linters and stuff. This is simple enough, so I'm just gonna copy the config that I needed. Is this store called my app? No, it's called server.js. Server.js. And then we can kill the old one off because we're done with it unexpectedly. And it should launch. Nope, it's not launching. There's some kind of error. What kind of error was there? Cannot find module. Okay, hold on, calm down, calm down, calm down. Open in terminal, npm install, there you go, shh. It's gonna be okay. Relax, relax, relax. Forgot about that. We got to install. Okay, will it launch? Seems to have launched. No errors. Yeah, we're not going to see anything, but it is running. Cool. So what we need to do is add it as a dependency in your project and require it in the server. So npm install bcrypt, I guess. And then const require bcrypt. Do not remove notes. Place code between correct pair of notes. Okay. Oh, this is why I need it freaking prettier. Because whoever did this was trying to do the PHP standard. Oh my god. Like this. That looks bad. I can't do that, I'm sorry. It's not how that works. I'm not gonna butcher it. Cool. That should be require bcrypt. What else did they need us to do? Submit your page. Require it in your server. I think we required it. I think we're good. Let's see what happens. Yeah, we're good. Hold on. I want to test. Nope. And if I don't require it, the fuck? Still works? So how's it doing the tests then? Okay. Cool. Great. As hashing is designed to be computationally intensive, it is recommended to do so asynchronously on your server as to avoid blocking incoming connections while you hash. All you have to do to hash a password asynchronous is call bcrypt.hash, my plaintext password, salt rounds, error hash, store hash in your database. Add this hashing function to your server. We've already defined the variables used in the function for you to use, and log it to the console for you to see. At this point, you normally save the hash to your database. Now when you need to figure out if the new input is the same data as the hash, you would just use the compare function, bcrypt.compare. Add this to your existing hash function, since you need to wait for the hash to complete before calling the compare function. After you log the completed hash and log res to the console within the compare, you should see in the console a hash, then true is printed. If you change my plain text password in the compare function to some other plain text password, then it should say false. We've already defined it for you. What did you define? Define the variables used in the function. Okay. The hash is hash. Was it hash? Yeah, it was hash. Okay, and we want to know that it's actually working and not just pretending to work. Oh. Oh, it runs immediately, of course, because, yeah, okay, that makes sense. So, yeah, it's working. Add this to your existing hash. To your existing one's function. Oh, okay, right. Inside of the hash. Yeah. Okay. Just want to make sure. Password changed, and then res. And then we'll know if the password changed. True. Did it change? And then it said change my plain text password to some other plain text, and it should say false. Yep. Good job. Great. So that's working. Submit when you think you've got it right. Well, I think we've got it pretty damn right, so there you go. Hash and compare passwords synchronously. Hashing synchronously is just as easy to do, but can cause lag if you're using it server-side with a high cost or with hashing done very often. Hashing with this method is as easy as calling bcrypt.hashsync. Why would you do it synchronously? Add this method of hashing to your code and then log the result to the console. Again, the variables are already defined in the server, so you won't need to adjust them. You may notice even though you are hashing the same password as in the async function, the result in the console is different. This is due to the salt being randomly generated each time, as seen by the first 22 characters in the third string of the hash. Now, to compare a password input with the new sync hash, you would use the compare sync method, with the result being a boolean true or false. Add this function in and log to the console the result to see it working. Okay, so sync, start sync, there you go, and end sync. Do you want me to have result as well? Like so. What is this? Synchronous? So synchronous. And synchronous. Or we could just do password changed. Synchronous. Like that. And then set this to result. And then the hash. Synchronous. Oops. There. The hash, password change, true. The hash synchronous, password change, true. Okay, so if I changed this to just some other plaintext password, it should be false. Yeah. Perfect. And that happened before anything else because it was synchronous. Cool. Keep doing that. There we go. And we are done with the helmet section. Featuring bcrypt out of nowhere. Oh man. And now to do some crazy tests. Oh yes. Oh man. Tomorrow is gonna be a fun day. Test-driven design, TDD. Because I saw us using this in Node in some places. I didn't quite get how they work, but I thought it was pretty cool. So now we're actually going to be able to put that to the test. So tomorrow's going to just be an entire day of... Yeah, let's see how far we get, but chai and... maybe some advanced Node stuff like start with it or something. But I want to get a early start tomorrow, so we'll come back to this. But so far we managed to, in this almost hour and a half, complete the helmet section with bcrypt. That was pretty straightforward. I mean, helmet pretty much does everything for you. You just have to understand what it's doing and configure it. And we already knew how bcrypt worked prior. But the test stuff I'm really looking forward to. That's something I can actually use in a lot of things. And also I want to integrate helmets into our other project. That's something that I feel is beneficial. But yeah, that's gonna be fun. Let's see. Cloning this repository. Mocha and chai. Delicious. You can tell these are 3 years old. Can you believe that? Wow. Imagine how much would have changed when they bring about the update, which should come anytime. I think it was version 7 of Free Code Camp. Powered by, set it to dead mono. That could actually be really cool. Just powered by myself. But yeah, I'm looking forward to continuing this. This is so exciting! Just this and the advanced node and express stuff, and then we can actually start working on the projects. And we're gonna utilize everything that we've learned, like collectively through this entire experience to put these projects together. So that's gonna be fun. But yeah, until then, tomorrow, later today, I'll see you guys on the next one. Bye for now.